Oh, I'm so small.
Small Whitney. I don't know how that happened. Okay, let's put this. There we go. You're still small, but hey.
I'm just a little devil on your shoulder. No, this is not okay. Let's do it like that. Hello, welcome. Now our heads are about the same size, right? We're trying something new. We're messing it up already, but it's color, right?
Yeah.
Anyway, welcome to You Choose, the Choose Your Own Adventure style journey through the CNCF landscape. And we're on the grand finale of chapter 4. So it's just me and Victor today, hanging out with you. We just got back from KubeCon. How was your KubeCon, Victor?
Exhausting.
Yeah. Is it ever not exhausting? Yeah. I want to say hello to Zoe, who's a university student who said hi to both of us at KubeCon and is a fan of the show. So awesome, Zoe. Thanks for watching. And way to be a woman in this space. I'm rooting for you. I'm rooting for everybody, but also Zoe. Thanks for saying hi to us at KubeCon.
Hi, Carlos.
Hi, Carlos, too. Hey.
And Nikos and Wojciech and whomever is appearing in the comments. Hello.
Victor, I need you to, if you can manage the comments. I actually can't see them right now because my monitor's messed up.
Yeah,
so
there are good comments already flowing in. Like, hey, Whitney, your voice sounds like the one on Google Notebook LLM's AI-generated podcast. Is that you?
Does the LLM have losing their voice from talking too much at KubeCon? Is that how they're doing it?
It can be trained.
Yeah, yeah. So we're going through all of the choices. So this is probably going to be, in the past, these streams have taken a couple of hours. So get a drink, hang out, ask your questions. The very first episode, we talked about dashboards. And even from the very beginning, I was already confused because I was imagining Grafana dashboard and not a Kubernetes dashboard. So we were talking about all the different CNCF projects that visualize Kubernetes components.
Well, if Grafana dashboard was in CNCF, it would be there.
It also does Kubernetes and not just observability statistics.
I mean, it's a dashboard, completely different than other dashboards that we explored, but hey.
We didn't put Percy's in the dashboards episode. We put Percy's in MISC, and Percy's is a dashboard, but it does observability.
Yeah. They came too late.
So we decided to call episode 1 Kubernetes dashboard, and we covered 3 projects. We covered Kubernetes dashboard, and we covered headlamp, and we covered meshery. So my first question is, do most organizations have some sort of Kubernetes visualizer? Is that normal?
If you're talking about resources, navigating through resources, not
Yes.
kind of not like metrics and logs and stuff like that, many do.
Yeah.
People like clicking buttons.
Yeah.
What's wrong with that? Whitney, you're disrespectful now.
I think it's definitely beneficial to have a visual view of what's happening, and maybe a source of truth that 2 people can look at and agree upon what's happening. In fact, meshery, so I think the difference between those 3 tools is scope. Do you agree?
No, I think that scope is give or take the same. Kind of like the scope is essentially, hey, how can we visualize what's happening in our cluster, right? If you look at the scope from that perspective, it's the same everywhere. Now, of course, those tools are not all doing the same thing, obviously. There are, Kubernetes dashboard is kind of, hey, it is what it is. Mesher is a mishmash of many different things. It's even hard to define, but there's a lot of things going on there. And headlamp, think of headlamp as being Kubernetes extensible Kubernetes dashboard. So it's like Kubernetes dashboard. When I say Kubernetes, I mean from Kubernetes SIG, right? But it can be extended to infinity, right? So I just heard maybe a few weeks ago that, for example, Headlamp is the first not commercial UI for Flux, for example.
Yeah.
Right.
Yeah,
Because
yeah.
it can be extended to anything.
Okay, I'm gonna respectfully disagree and stick to my scope thing. So Kubernetes dashboard is just a visual representation of Kubernetes APIs. It's as close as you can get to the Kubernetes APIs. And I guess there's some security issues too that come with that, and part of why it's maybe not super widely used. Headlamp does have the wider scope. It's an extensible Kubernetes like a visualization framework where you can add plugins, you can add a Prometheus plugin, you can make your own plugins, you can make it organization specific. It's also an adaptable UI, so there won't be a button to edit something if the organization hasn't given you permission to edit that thing. And then, like you said, it would love to be the UI for all of the CNCF projects that don't currently have a UI. That's the dream, and Flux is the first one that I know of that's on board for that. Then Meshery isn't Kubernetes specific. So with Meshery, you can visualize CNCF projects, but you can also visualize other cloud resources. And it's more like a way to collaborate around cloud resources and have a source of truth. And it's like Google Workspaces, like Google Docs, but for your cloud resources. So you can comment on them, you can suggest changes, you can approve changes, you can like work in a collaborative way through this UI on a lot of cloud things that aren't Kubernetes specific. What do you think?
I agree.
You agree? Awesome.
Yeah.
High five. You can actually see.
There,
Awesome. So those are our UI projects. And which one won the vote?
Headlamp.
Headlamp. Let's demo Headlamp.
Yeah, let me put my screen on. There we go. I mean, this is going to be probably the shortest demo we'll do today. I already installed. By the way, I will be installing in the background while Whitney is talking the other projects, just not to bore you too much with the setup, this or that, Helm install, what's or not. Anyways, here's Headlamp. It's, you can go and navigate and see the pods, see the deployment, see the stateful sets, and so on and so forth. Basically, you can navigate then through all the resources and then in separate section, storage, network security, what's or not, right? So it's pretty straightforward. There is not much to talk or explain. Now, actually, there would be much more to talk or explain if I did bring in some plugins or put my own and stuff like that. But right now, I'm just running Headlamp as is. So from that perspective, it's similar to others until we start extending it, right? I have a tiny complaint. I just realized for the first time. Why is this not clickable? Okay, anyways. Headlamp. That's a Headlamp. Quickest demo ever. Try it out. It's free. And it's cool. I really like it.
It is cool. Okay, so then episode 2 was open standards. And we didn't have a vote for episode 2. And it was OpenTelemetry and Prometheus. Why did we feel the need of having this at all?
The need to have open standards?
Yeah, why did we do this episode?
Oh no, why did we do this episode? Nobody knows. Why do we have the need for open standards? That's so that, basically, I mean, depends. From the vendor perspective, I'm not sure that vendors like open standards in the first place, at least bigger players. But from the user perspective, basically, the idea is that, hey, I can have stuff defined in a certain way, and then that stuff, whatever that is, I'm talking in general, will work across the board, right? I could switch from one tool to another without much trouble. And OpenTelemetry is definitely one of those.
So both. So we had on a guest from the OpenTelemetry project and one from Prometheus, and in some ways they work against each other because I think they can all be used for all levels of observability, which we'll talk about later. But also they both can. Oh, do you want to say something about that?
Yeah, they're curious because both OpenTelemetry and OpenMetrics are in a way standards, but from a very different perspective, right?
Yeah.
OpenMetrics is essentially, it's not a standard adopted by tools that collect metrics. It's basically Prometheus, that's it, mostly. What makes it very special from a standard perspective is that most of the tools that you will be running in Kubernetes that somehow need some data, some metrics, will assume that you're using Prometheus before anything else.
Yes, for metrics, definitely. And that's what I wanted. I think for me, I think the open standards episode is important because even both of the guests could agree, like you can't do tracing without OpenTelemetry. There's no robust tracing solution without OpenTelemetry. There's no robust solution that includes metrics that doesn't also include Prometheus. So to vote on these projects doesn't make a ton of sense. Like they're included in everything, like it or not. So, so talking about, do you need both? Do you need one or the other? You're both trying to standardize the field. What does that look like? And we had a really cool conversation. But to talk about these projects, like there's so many points where data is being collected. So to talk about Prometheus, like your third-party apps are going to generate Prometheus metrics right out of the box. You don't even have to do anything. And same, so like Kube API is generating Prometheus metrics, Argo CD is generating Prometheus metrics. And then if you want your internal applications to generate Prometheus metrics, you can do that. You just have to add a library and then have all of these things generate Prometheus metrics. So some does it automatically. Sometimes you add a library. And then for other things that you might want to generate metrics that might not out of the box, then you can do Prometheus exporter. And now you can make metrics for something, say, at the node level. So I'm, for those of you who don't know this, like I knew about nothing about observability however long ago we started this, 3 months ago. So part of what it is for me is I just need to understand what Prometheus is and what OpenTelemetry is. And coming from zero into, okay, what's Prometheus was actually a big leap because Prometheus is like how are the metrics generated? So there's like exporters, and then how are they collected, and like scraping, and then how are they ingested, which is put into storage, and that's also the storage itself is built into Prometheus. So there's so many levels of what it is, and similar to OpenTelemetry. What do you think about my synopsis of Prometheus? What else do we need to know, and then we'll talk about OpenTelemetry.
I mean, you were talking mostly about, hey, generation of metrics that is eventually pooled by Prometheus. To me, just as important, or actually probably even more important aspect of Prometheus is that tools that will need metrics but are not directly focused on observability are almost certainly going to start with Prometheus.
Yes.
Right?
Okay.
Kind of, if there is a tool that needs metrics in some form or another, and that tool is designed for Kubernetes, and that tool supports only one source of metrics, that is going to be Prometheus. Right? I'm not saying that there are tools that support others, so I'm not saying that that's the only one. But if a tool can choose only one or starts with one, it's going to be Prometheus. And we're going to see that later, for example, with when we get to progressive delivery, both of the tools in that area do not work exclusively with Prometheus, of course, because they matured over time. But if I'm not mistaken, in both cases, Prometheus was the first implementation of, hey, I need data to make a decision. Where is that data coming from? Prometheus. So
Prometheus comes before logs?
In our story, or
Any way you want to cut it. I want.
yeah, so I mean, I would say that you cannot live without logs. So if you would ask me, hey, there is only one type of data that you can fetch, that would definitely be logs before anything else. Now, if you say, hey, there is only one type of data I will be collecting from Kubernetes, then I would change the story and say metrics, because logs I can already somehow see from, by executing kubectl logs, what's or not. So I've seen companies that do not collect and aggregate logs, but they still have it somehow. But Prometheus, yeah, definitely is a starting point. It's just to be clear, I'm not saying that everybody should start with Prometheus, but actually I do. Everybody needs more Prometheus. Yeah.
Why is that? Why did you change your mind?
Because of what I said before, you are inevitably going to get to the part that you need some tools that need data, metrics. And if that tool doesn't support whatever you chose, it still supports Prometheus. Right? So let's say that you, and I'm using this example just to demonstrate. Let's say that you as a company, you chose to use Datadog. I'm just naming a random one, right? Everything goes to Datadog. Great. You're still most likely going to have to run Prometheus in parallel.
Okay. Interesting. Okay, let's talk about OpenTelemetry. I have a gap in knowledge that I'm interested in. So OpenTelemetry, which people call OTel, so generating metrics for OTel. So it wants to be ubiquitous. It wants to have built-in. It wants to be built into every tool, but I don't know that it is. I know that
ubiquitous and obese.
And obese.
Yes.
It wants to rule the world. I don't know.
No, more kind of like fat. Basically, it supports any variation that anybody could come up with, and that's probably potentially one of the biggest downsides of OTel, right? Kind of, it's a compromise that includes everything.
So it's a specification, and that specification, it is like hundreds and hundreds of markdown documents about every little possible thing you could define related to telemetry data and software collecting and doing stuff with telemetry data. So first and foremost, it's a specification, but then it's also a transport protocol, which is OTLP, and then it's also 3 kinds of software. So it's APIs, SDKs, and collectors. And not just one API, because that'd be too easy. It's like a lot of all of those things. Several versions of all of those things. So it's, when people just say OTel, a lot of times they're talking about the transport protocol. Like I receive data from OTel, they mean I receive data in OTLP format. But one thing that's hard when trying to understand OTel out of nowhere is that people might call any of these things OpenTelemetry, but they're all different aspects of OpenTelemetry. So what I do understand from the OTel model is like you use OpenTelemetry APIs, like language-specific APIs, to instrument your application to omit telemetry data. But what I don't understand is, how is telemetry data emitted from third-party applications? Do you somehow instrument that?
That depends. Kind of, I mean, it's third party, so you don't have a control over that, right? Now, the authors of that third party might have chosen to emit OTel data.
Is that common?
I would say less common than Prometheus. Within Kubernetes area, right?
Yeah. So then from the API, getting the data from the APIs, then it can go to OTel SDKs that can do cool things. Most remarkably is it correlates all the data that's coming from all over the system. And OTel is like, right, like the way it used to be done is people were collecting logs, metrics, and traces without a good understanding of how those all relate to each other. And so now with this OTel system, you're giving all the context at this moment. Like you can understand everything that's happening at the system at a point in time. You can understand whether a certain data is part of a larger transaction. You can you'll understand how even the metadata is standardized. So then you can get it into the OTel SDK and correlate it to get a holistic picture. Then if you want to change the data at all, it can go through a collector, which is a data pipeline. And then from there, it finally goes into storage and visualization. So that's how OpenTelemetry works. Yeah? Did I get it? Is there anything you'd like to add?
I mean, the only note I would add is that the collector is optional.
Yes, 100%.
So basically, you can push from your app basically to collector, or you can push from your app directly to a tool that actually will that data.
Yeah. So at a high level, these are different ways, and honestly, you're probably going to use a combination thereof of these two different ways when you're implementing your observability solution. Yes.
Yep.
Yep.
Exactly.
And is there anything else?
By the way, if anybody has any questions in the comments watching this right now, just write them down. And actually, questions or statements, kind of like, hey, Victor, you're talking silly. This makes no sense. You have no idea what you're saying. That's also fine.
Yeah, please correct me too. Or just tell me, I don't know what this drawing is. You just introduced a new element into the show. It didn't even acknowledge it. Is there anything else we should say about standards that you think? Do you want to talk? One thing the guest talked a lot about during the episode was like the push versus pull model, where Prometheus pulls in the metrics once a minute by default, and OpenTelemetry pushes its data in. And they both had really strong opinions, and I didn't take any opinions of my own. Did you have any thoughts about that part?
No, not special, to be honest. Kind of like
okay.
Most of the tools prefer push-based model. Prometheus is special. Not the only one, but one of the rare ones that prefer to pull data. Pull data is also so pushing. We've been doing pushing forever, for decades, right now. When Prometheus first appeared, I was shocked, to be honest.
Yeah.
Kind of like, what do you mean pull data? Are you insane? But that was also when I was shortly before that I was shocked to learn about service discovery. So it's fine.
Being shocked doesn't necessarily make it a bad thing. I'll say too that they work together. Like the Prometheus is starting to work with the SDKs, or the SDKs, I forget which side it's coming from, but the SDKs can take Prometheus data and correlate it with the OpenTelemetry data that it's gathering. There's some overlap and some collaboration between the projects too.
A quick answer to James. We will be coming to Traces soon, so
yeah,
it's coming.
It's coming. But next, we did an episode about metrics. So in that episode, we talked about, I'm going to get out the glass cleaner. We talked about Cortex and Thanos and Prometheus.
And for the sake of my sanity, I'm going to change the order of things and confuse you completely and put Pixel into the same group.
Okay, sounds good. Tell us why you want to do that.
I mean, it collects metrics, traces, what's or not, just as Prometheus does, except that Prometheus is only about metrics. So basically does what metrics tools are doing, plus whatever tracing tools are doing. So I feel that it belongs in the same category, or both categories, let's say.
Okay, I like it. It's better. The miscellaneous category is just, it does, the tools aren't in context with one another, so it's nice to give Pixie some context. So so Cortex and Thanos. So when you have Prometheus running across a lot of different instances of Prometheus running, I'll put them over here. You start to have problems when you try to scale Prometheus. So the different instances of Prometheus are each scraping different data, but there's no way to query that data from one place. Unless you have like a central Prometheus, I'm going to give this one a crown, that scrapes the data from all the smaller instances of Prometheus, which are called leaves. But that's not a great solution because it's slow to query. Like Prometheus doesn't work well when you start to get super large amounts of data. So it doesn't scale really well for that reason. It also isn't highly available, and also you can't keep your metrics for a long period of time. You can keep them for 14 days by default. And if you try to keep them longer, you run into that big data slowing everything down
keep
problem.
it. Basically,
okay.
You're going to the point that if you leave the drawing as is but change that one prompt to something else, that's the solution.
Yes.
I just saved you a bit of time, that's all.
Kind of. So we'll call this Thanos. And we'll call this, this is the Thanos querier. So Thanos is a toolkit of components that sits on top of Prometheus, and then it helps it be scalable, highly available. Like you can treat it, you can query it globally, and you can put stuff into long-term storage. So there are Thanos sidecars that run alongside each instance of your Prometheus. And then you have a querier that communicates with all the sidecars, but then also there's a compactor component that I forget the names of all the components, but there's a component, I think the sidecars actually move the data at some point in time to the object storage, and then the querier can also query the object storage. What's cool about the querier is when you need to find metrics, you don't need to know, are they in my long-term storage? Are they on one of these instances? Like you just ask for the stuff and it gets the stuff for you. And it's stateless and scalable. And there are lots of other components I'm not mentioning, but that's basically how Thanos works.
Don't delete everything. Just now change Thanos to Cortex.
Well, Cortex doesn't have sidecars. And with Cortex receives the data from Prometheus, but it's architected completely separately from Prometheus. So it doesn't know or care who's sending it data. And in fact, you can get OpenTelemetry sources might be sending it data too. And then Cortex, this is a distributor component. And then the distributor will send it to however many ingesters that you have in your environment. And then you have high availability and redundancy, and these will send it to long-term storage eventually, the object storage, and there's also compaction. And but the big thing is Cortex architecture is completely independent of whatever your Prometheus or whatever your metrics looks like. So it does all the same things, but it's if you don't necessarily have a large Prometheus footprint, it's good. Or if you, it's especially good for multi-tenancy solution. I'd say Thanos is good if you have, like, Thanos says they can store billions of time series metrics. I think they said infinite amount of metrics for an infinite amount of time. I think they're good for
storage.
And yes, as long as you pay for your infinite amount of hardware.
And infinite network bandwidth.
And then Pixie, I don't know if Pixie's worth drawing. Pixie is Pixies go operating at the kernel level and getting metrics. There's a Pixie component that's on every single node, and it's using eBPF to collect metrics at the kernel level. It's collecting protocol traces and network metrics and resource metrics and app profiles, whatever that means. And it has one dashboard where you can query globally without understanding the distributed nature of the data. And then you're only meant to keep the Pixie metrics for 24 hours. Like it collects a tremendous amount of data, and then it's only meant for 24 hours debugging. It's not meant for long-term trends. You can keep it long-term because of that OTLP format, but once you send it away from Pixie, you can't use the Pixie dashboards to look at it anymore.
Depends how you look at it. If you say, hey, Pixie is primarily to see the current state of my cluster and debug the issues when my production goes down. If your production is down for more than 24 hours without you figuring out, you'll be fired. So you don't need longer storage than that.
Yeah, but
you're out.
There's a difference between like something slightly wrong that we can look at versus my whole production's down. There's like a whole spectrum of issues that could happen between those 2 points that Pixie could maybe help with.
Nobody cares about those. You don't have time to fix those.
Yeah. So that's Pixie. And our vote was only Thanos, Cortex, Prometheus. And what did the people choose?
They chose Cortex or Thanos. But I remember it's one of those 2.
They chose Thanos.
Thanos. I knew it. I had 50% chance to guess it right.
You didn't actually guess either one, though. Cool.
You didn't let me. You interrupted me. I would have guessed it correctly.
I believe you, Victor. All right. Well, show us a demo, friends.
Yeah, so I'm not going to show demo of Thanos, mostly because my cluster is too small for that. And it would completely burst if I had the full thing. So, but I did set up Prometheus. And I'm not going to show you Prometheus either. I mean, actually, this is Prometheus, right? And I can query anything I want. Like those are all the metrics that are related to Kubernetes. But the reason I'm not going to show much because I will go back to Prometheus later when we get to progressive delivery, because at that moment for us to figure out what we're going to do with progressive delivery, we need to figure out how we're going to query data, and we're going to do that from Prometheus. So Prometheus, apart from me installing it while Whitney was talking, is not going to be shown right now. But I am going to just prove. I'm going to open until we get to progressive delivery, what's or not. There is also Grafana that I installed, and I can quickly show you what's the password, admin, and I think it's from operator. There we go. I don't know what is this question. This is too much small. There we go. If you take a look at the dashboards, I already loaded a couple of them. Let's say pods, right? I want to see something about pods. Let's say this one. I don't know, whichever this one is, right? And then you see all the information. This is basically the same information that is coming from Prometheus, except that I picked a silly data source. Let's say node. Okay, this is node dashboard for pods. Doesn't matter. Anyway, what does matter is that hey, we are connected to Prometheus. Prometheus is collecting data. It does that out of the box, and then you fine tune if you want something extra. Actually, many of the tools that you will be installing later on, we're going to install Istio, for example, and you will see that Prometheus will pick it up automatically. And this is a proof that we can query data, because this thing here just shows that that I've been running Prometheus for only 15 minutes now. Anyways, that's a quick one. It's quick because we're going to come back to Prometheus later when we get to progressive delivery.
Cool. So that means, is there anything else you want to say about metrics at all before we move on?
Nope. If you don't collect metrics, you are in a really bad place. That's the only thing I'll say.
And it's maybe a little too late to mention what a metric is. If you didn't already know, you probably have turned it off by now. But a metric is a piece of data at a point in time. A numerical measurement specifically at a point in time. And you can collect...
Everything is a piece of data at a point of time. Logs are a piece of data at a point of time, but metrics are numbers at a point of time, associated with something.
Yes. And so, so next up is tracing. So with metrics, you might be able to say, hey, when someone checks out from our application, it's really lagging. But you don't know why or how or which component is lagging. And so that's when, if you're collecting traces, that's when you can use traces to help. So trace is like one particular request and how it moves through the system. So it goes to the checkout app, the payment happens, it goes to the inventory, and then I did it. I bought an electric toothbrush. And so all of this together is one trace. And then each one of these green arrows is a span. And that's tracing. Span. Not to be confused with the canned meat. So all of this would be considered one trace. So one request response, and then one of these is a span. So that's tracing. We have two tools that can do it. Is there anything you want to add to tracing in general?
No, I mean, my understanding, the main problem that, the way I see it, I mean, of course, tracing has many, many usages, right? But the main one is, okay, I have many applications involved in that request. How the heck do I know what's going on with the request?
Yeah. So it could be like you to find and fix a problem. Maybe you can identify latency issues, even more subtle latency issues too, to really tweak performance and optimize it. And also, I've heard that tracing is good. Sometimes you might have services running in your system that are just never touched and never used. And you can find a dead service with tracing too that you otherwise might not be able to see. Yeah?
Yeah.
All right. So our tools then were Jaeger and Zipkin. The big difference is that Jaeger is all in on OpenTelemetry. So Jaeger used to have tracing SDKs, it used to have agents that run on every node. It used to collect its own tracing data. And now it's like, we don't need to do that. OpenTelemetry is doing that. We're trusting OpenTelemetry to generate all the data we need. So we'll just get the data from OpenTelemetry, and then we're going to store it, and we're going to visualize it. And that's
if I'm
Jaeger.
not mistaken, the first iterations of OTel were basically Jaeger format.
Yeah, OTel used to be Open Tracing, was what it used to be called.
Which used to be Jaeger.
Which used to be Jaeger, okay. So there you go. So Jaeger is all in. And then Zipkin is older than Jaeger, and it relies on these older components, but then also it supports the more legacy type stuff in a way that Jaeger doesn't. Is there any, but the end is the same, where it gets tracing data, it stores tracing data, it visualizes tracing data. The Zipkin UI is dated, though.
I mean, functionally, they're performing the same function. Mm-hmm. Yeah, kind of collect traces, whichever format it is, show it to people.
Uh-huh. Yeah. And that's that. Is there something, I just blew right through traces. Is there something else you wanted to say? Or does, James, did we answer your question okay? Do you have any question, anything?
Yeah, James asked about what was it? This is kind of important to talk about. We're considering Mimir. Mimir is awesome. So yes, go for it.
Mimir
We
is
are
a
not
Grafana
talking
thing.
about Mimir because we're trying to focus mostly on CNCF. If you see non-CNCF project, that's mostly because, hey, there is only one. Let's bring in somebody else, like in case of tracing. But yeah, Mimir is awesome. Yeah, use it.
So when you implement tracing, I understand that, well, with almost all of this stuff, observability, no matter which signal you're collecting, you can generate tons and tons and tons of data, and it can be inhibitive from a cost perspective and a performance perspective. So there's a lot of figuring out how to best filter your data to get what you need, and at the minimum amount of storage and performance cost. And that's not something we talked about during this at all. We're just talking about how things work. But I understand what traces, that's one big part of implementing tracing. And then similarly, like Jaeger relies on the OpenTelemetry to get its tracing data, but if you tier your collectors, which we'll talk about collectors next, then you can start to mess up the data that OpenTelemetry is receiving and lose your trace data. So you have to be careful when you're architecting your solution for that reason.
Yep. Let me bring in a couple of questions from James.
I love that.
You mentioned dApps being instrumented by the OTel SDKs, but I'm also more interested in auto-instrumenting with newer stuff that gives you traces either from your service mesh and now eBPF. So you do need to instrument your apps, as far as I know, to give you traces, because as a bare minimum, there must be a process that checks whether a request already has an ID attached, trace ID, and if it doesn't, then it's a first in line, and that something needs to add that ID, generate and add the ID, or if it already has it, to respect it, right? So something needs to identify requests, right? So that they can be tracked across requests. Now, you can also instrument almost anything these days, right? So, or you can choose not to auto-instrument, or you can choose to auto-instrument and manually as well. The question you need to ask is whether auto-instrumentation can be on different levels, actually, right? You can say, hey, some kind of sidecar or eBPF or what's not, and that means that you will be able to trace requests flowing through your system, but the smallest granularity is your application, right? You will see, hey, let's say that you're interested into duration of a request. Hey, it spent this amount of time in this application, this amount of time in that application, and so on and so forth. If you need more than that, then you can auto-instrument your code inside. You can use libraries that provide that. So for example, I tend to write mostly Go, and I don't know, let's say I'm using TinyGo, and then there is TinyGo library that instruments it with automatically, right? Without me adding much in my code, except maybe 1 or 2 lines. And that will give you smaller granularity, and you might say, hey, this is enough, right? Or you can say, no, I want to know how much time it passes between each function within my code, and then you need to edit yourself. So it depends on the granularity you're interested in, right? Sometimes auto-instrumentation works from outside apps, sometimes inside, more granularity. Sometimes you use libraries and add a few lines to add traces yourself, right? Spans, sorry, not traces.
What's an example of something high granularity you might use instrumentation to capture?
So let's say that I have a request, I have a web server of some kind, right? And I auto-instrumented it by using some SDK that auto-instruments my web server. Cool. And let's say that request passes through 5 functions within my code until it goes back or forward somewhere else, Right? Now, if I want to know how much time, and I'm using time as measurement here because that's the most common. If I want to see how much time it's spent in each of those functions, I need to add code to my functions that will add additional spans, right? So think of span as being, one request is split into spans, and the more spans there are, the higher granularity in a way.
Yeah. So maybe
And there
more
is
bounce around.
another question from, by the way, if I don't answer or I misunderstand your questions, just type more. Can I use tracer in Istio without implementing into the app code? Same answer as before. Yes, if that's all you need, right? Sometimes you might, so let's say that you deduce that your application is one of the 5 applications involved. How many do you have there, Whitney? 3 applications in Whitney's case. Or 4 applications in Whitney's case, and you find out that the second one is slow. If that's good enough for you, great. If you want to know which part of that application is slow, then we're talking about manual instrumentation, which is not hard, by the way. And let me see whether there is something else, because before we continue, we have Istio Envoy emitting traces based on requests going through the mesh. We also have basic instrumentation coming from Spring Boot, etc. Yes, that's basically you're covering now the 2 of the 3 categories I mentioned, James. And sometimes our developers don't choose to include Micrometer Java SDK for instrumenting their applications. That's fine. No, or not fine. I don't want to enter into the fight with your devs.
You do you.
Exactly. And finally, it seems like the hottest stuff is using eBPF for everything. Not necessarily for everything, but yeah, eBPF is awesome. Hubble included. So yeah, eBPF changed a lot of things.
As far as I know, though, they've tried hard and haven't figured out a way to use eBPF to trace all the spans of one particular request all around. Like you can see full request response bodies at any given moment, but you can't figure out how it's moving from component to component with eBPF alone.
Because, and this is the area where I might be wrong. Actually, every area I might be wrong, and I'm most likely. But basically, the requests that are passing through eBPF are probably lower level and might not even have that information attached.
It does have, they can, like Pixie, for example, can see full request response bodies. Like part of the design of Pixie is to be careful to make sure that the data never leaves the node it's generated on, because it can contain sensitive data.
I mean, what is likely, and I think that James is pointing to that, you can trace with eBPF, but something still needs to attach that ID. And eBPF alone cannot know where it starts, right?
Yes.
Because
exactly.
Theoretically, in Whitney's drawing, that ingress, request from ingress could go first to any of the 4 applications, right? So it has no idea where it starts. Okay.
All right. So you're going to, the one that won is Jaeger, which is good because it's the only one that's CNCF. If Zipkin won, we still would have demoed Jaeger. And Victor, you're up for a demo. I erased my
Here we go. Okay, so this is my application. I'm using YTT mostly because that was a choice before. There is nothing really special here. The only reason why I'm showing this is here, right? Basically, my application, you need to trust me that the code already has instrumentation inside. And I'm enabling that instrumentation through, in this case, environment variables. And I'm telling, I'm essentially telling, hey, the endpoint is my Jaeger instance running right now in the monitoring namespace. Whenever something comes, whatever you send through there, instrument it. If it's not instrumented already, propagate IDs, what's or not, and treat this as the application called CNCF demo, right? And I'm interested in trace contexts. I'm mostly not interested in whatever else is available there. And what I'm going to do is I'm going to commit this and push to Git. The reason why I'm doing that is because this is ongoing demo, so everything you chose before is still available. And in this case, we're using Argo CD. Now, what you will see is that at one moment, if this works, that this pod here will be shut down and a new one will be created, and it will have two containers, right? Not one. There will be a second container that is a sidecar container that is dealing with tracing. And let me split screen here while waiting. No, wrong one, wrong command. Layout. I think this is the one. Okay, cool. So let me. What did I do before? Yeah, kubectl cutl namespace production get pods. So this will. Why? Pods. There we go. This will eventually change, and while waiting for that, let me see where is my Argo CD to. What did I want to do? To speed it up, right? Because it might take a while. What is the Argo CD address? I forgot. Okay, let's do this. Where is Argo CD? Argo CD. I don't have Argo CD ingress. That's embarrassing. Let's do this. Let's do kubectl dash namespace Argo something. There we go. Port forward to SVC. What is the service? Argo server 8080 goes to this one. Okay, now I should have Argo CD and no need to speed it up. There you go. You see that it killed the pod, and now there is a 2 out of 2 containers in this pod. That means that it is instrumented. Now, while that is happening, I'm going to execute. I'm going to start bombing my application request so that you see something, and I'm going to open Yager for you to see the requests coming in. It's a simple application, so you will not see a very complex setup here, but enough to see that if I select CNCF demo, and if I say find traces, you can see that traces are here coming. Each request is a trace here. You can see that I'm sending only GET requests, and you can see the distribution over time and what's not, right? Now, of course, this is a single application, not much going on with Ingress. If you would have something closer to what Whitney described, this would be more interesting. But the important part is that my application is instrumented, and those traces are being collected. And then we can move to the next subject. We have kind of limited amount of time, so I'm keeping demos relatively short. Yeah?
Yeah, we have a lot to get through.
It's a pipe.
It's a
look
pipe.
at you. Okay.
So we have
Sewer pipe.
it's like a Super Mario Brothers pipe.
Okay, so not a sewer pipe. Okay.
Which maybe, I mean, Mario's a plumber, right? So maybe the Mario
true.
Brothers are just like, going down with the poop tubes. So telemetry data pipeline, there are, for our choices, we have the OpenTelemetry collector, which we briefly mentioned before. We also have FluentBit, which is evolved from FluentD, which was all about logs. They basically are a data pipeline now. And then the third project we talked about is one called Logging Operator that works on top of either of those two. But a data pipeline can get data from one or many sources. So some examples of sources would be OpenTelemetry SDK that we've talked about, the FluentBit daemon, maybe Prometheus. Maybe you could get data from if you're using service mesh to collect data. I don't see why not. And then a pipeline itself is made up of 3 parts. There's like the collector element. There's the processing part. And then there's the exporting part. And so you collect the data, you do whatever to it to process it. So maybe you drop personal data, maybe you filter, and so there's less data you're storing. What's something else you might want? Maybe you join data with other data from different sources. Those sorts of things. Remove
as well.
Yeah. And
And
then
then
you
yell
can,
at people, why am I wasting my time removing you
why did I
your
collect
logs?
it in the first place? Yeah.
Yeah.
And then you can export it to one or many storage places. So maybe you have two duplicates of the data going to two different places, or any combination thereof. And that's what a pipeline is generally. Is there something you'd want to add to that?
No, ship it to the pipeline transforms it or it doesn't, and ships it further.
Yes. And so the Fluent Bits project is basically its data pipeline, and it is it's optimized for efficiency. And it's also because they came from a place that was once Fluentd. They know their way around logs. And so it's optimized to do great things with logs. And similarly, the OTel collector is optimized for traces. So those are like the differences between the projects.
I like how you said without saying it works well with traces, but don't use it for anything else, logs or metrics.
Oh, and they both are fine for metrics. Like, I guess one's not better than the other for metrics.
Yeah.
The FluentBit project has tried to make theirs pluggable, where they maintain the image, but then you can add your own bit of processing, so that's to make like your day two maintenance easier. So that's a benefit of the FluentBits part. But then OpenTelemetry collector, one thing that maybe makes it better for day two is that OpenTelemetry just has such a huge community, and so many collectors already made and written and such. But the differences between the different pipelines are, the different collector projects, I think, are pretty small, honestly. What do you think?
I agree. While I'm preparing the next
Your next
part.
thing.
Yes.
And then the third project, I'll write these down. So we have OpenTelemetry collector, our three choices for voting, and then we have FluentBit. And then the third one is logging operator. So it does a couple of things. It helps it. So like a lot of things, logging operator has figured out, hey, we can change our project a little bit, and instead of working with logs only, we can work with all of telemetry data. So they're in the process of doing that now, and our guest at the time, he showed us some examples of what they're doing for telemetry data generally. But in general, what they do is they provide a custom resource that teams can use to manage the logs or the telemetry data of just their particular application. So they can have opinions about back pressure or where it's going without having to see the whole picture. So it's good it has a nice dev-facing resource that abstracts away a lot of the complexity of log collection and transport. But excuse me. And then it's also good for multi-tenancy in general. So you can isolate logs from one another so teams can't see each other's logs. And solves
You're
the
going to
noisy
die on us here?
Yeah, but this is how I want to go, Victor, if I go. It's a good way.
Publicly.
Talking about logs. The noisy neighbor. It can help solve it. You can add isolation and limits for different teams with logging operator too. So one team doesn't use all the resources. And those are our projects for data pipelines. Is there anything you'd like to add?
No, I think you covered all of it.
Awesome. And any questions?
It's in, change out. I don't know why you talked for more than 2 seconds.
Trying to say what's different about the projects. It's true. I take it. So the winner, the chosen one is OpenTelemetry collector.
Yes. which I did not prepare. So we're going to
Ah,
skip that
okay, right on.
part. Yeah.
So
But basically,
yeah.
you install it, you install it and change the address. So for example, if you paid attention when I show you the definition of my application, it was pushing directly to Jaeger in this case. If I installed collector, it will be pushing it to the collector, and collector would be pushing it to Jaeger, right? So from the end user perspective, it's the same, give or take, different address, and the real difference is how you configure the pipeline.
And collectors are, you can chain them to one another, and they can be tiered. You can have one.
I mean, you can go crazy.
You can go crazy.
Yes, and you can also start wondering, why is everything slow in my system? Oh, I changed 57 pipelines. You look at Jaeger and say, why is this request slow? Because it's traveling through all my pipelines.
Yeah. And actually, as I mentioned before, if you tier your collectors, you start to mess up your Jaeger data, and it might not be able to string together the traces again.
Oh, yeah.
All right, so next up is progressive delivery. What's progressive delivery?
No, we're going to change from how we did it and talk
About
about
service mesh.
service mesh, simply because we'll need service mesh for progressive delivery.
Sounds good. What was our question before about service mesh?
What was the question?
Yeah, didn't we have a question in the chat about service mesh? Am I dreaming?
But Whitney, I'm over 50. 15 minutes is the maximum my brain can remember. I don't know. But if you are still watching, whomever asked the question, ask it again. And maybe I will not forget it the second time.
So
I'll put it on the screen right away so that there is no excuse for me to forget it.
So we did a episode about service mesh because so I learned about service mesh back in the security you choose chapter, and I talked to every service mesh project, and they all said we do security, we do networking, we do observability. Every project, Istio, Cilium, Kuma, all of them said it. Linkerd, they all were like this. We do all of these things, and then when I started talking to all the observability projects, nobody mentioned service mesh at all. It was like it didn't exist. So I have service mesh over here screaming, we do observability. And then observability folks, it's like with earplugs in, like don't even hear it at all. So I wanted to get to the bottom of that and have a conversation about service mesh and observability. So what does one need to know? If you have a good
The only
service
reasonable
mesh,
course of action in that situation was to bring both of them, like in school, kind of like, okay, now I will turn my back on you for 15 minutes. That's how long you have to hit each other. And then you apologize to each other and explain to me what happened in the first place.
it's probably good you only have one child. Not multiple.
Could be. Or maybe that's
Maybe
why I have only, maybe I had two. Who knows?
You just have one strong one now.
Exactly. It's natural selection with me.
So first question is, as someone like a systems administrator, what is the problem you're experiencing that causes you to add service mesh in the first place? Is it ever observability, or is it always going to be networking or security?
I mean, it could be. So theoretically, observability with service mesh is really awesome. And it could be observability, right? Kind of like you want to have more information about what is happening on a networking layer, right? And sorry, when I talk about in this context service mesh, I'm really talking about networking, just to be clear, right? It could be Cilium, for example, which is awesome also from the observability perspective. So now I doubt that that's the first thing on a list of when people start adopting service mesh. I doubt. It's usually something else. So to answer your question, usually not the main reason.
Okay.
But then they realize that actually this could be the main reason.
So then I'm a system admin. I added service mesh. I added it for security for MTLS. But now I need an observability solution. Should I reach for a full observability solution, or should I like see what service mesh could do? Is that enough?
No. So think of service mesh. So there can be tools within umbrella of the companies that do service mesh, and I will show one in a second, right? But first and foremost, it's you don't necessarily change the tools, right? You don't have to, and most likely you will do both. But is that service mesh gives you additional information that you can collect, let's say, to Prometheus, right? So later on, when we get to progressive delivery, I will be using whichever tool we choose for progressive delivery to query Prometheus, and it will query Istio data, which the moment I installed Istio a few minutes ago, Prometheus started already collecting.
So service mesh does do all three signals, logs, metrics, and traces, but it does it at the network layer. And it also uses OpenTelemetry and Prometheus.
Yeah, I mean, it's not instrumenting or not. That's not its main purpose. And logs, I'm not sure that it does.
I'm pretty sure it does.
Okay.
I think, but I can't tell you more information, except that's what Abdel told me. But the question is, what's an example of some observability data that you can see that it's good for, and what's an example of some observability data that it cannot see that is not good for?
The data is basically anything related to networking.
Give me a concrete example.
Concrete example later. For example, I will be collecting the data managed by Istio of the duration of the requests.
Okay.
Not through traces, but directly metrics to deduce whether. Sorry, not duration. Forget about duration. About the status codes of those requests. Right? Is it 200? Is it 500? Is it 400? And so on and so forth.
Okay.
Now, could I do it without service mesh? Certainly. So that type of data I could do without service mesh. But you asked for one example.
And what's something it's bad for?
Logs.
Okay. Just like anything happening within the application. Like the different functions within the application.
Yes, basically, you use metrics, and that doesn't matter now whether we're talking about service mesh or not. You're using metrics to deduce what is happening in your cluster, not on a much higher level, right? Oh, it's slow, it's fast, memory consumption, and so on and so forth, right? Metrics are usually aggregated data, right? So you don't see. In my Prometheus, I will not see individual requests, right? I will see, hey, the average duration of requests we collected, blah, 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 is over this period of time is this, right? Because Prometheus would go bazooka if I would literally ship it kind of every request and whatever else I'm shipping over there. It's more like you use metrics. The way I see it is that you use metrics and up to extent traces to find out that there is something wrong. And then you might figure out what's wrong with those. And if you don't, you're going to turn into logs. Right? And say, okay, I know that there is something wrong with this specific application. Let me see from the logs what's wrong. I forgot your question. I don't know whether I'm answering it, but
I have a new question now, and that is one thing I learned during the stream we did with the service mesh projects talking about observability is that Istio is all in on the Istio ambient, where they're doing some of their log collection with eBPF, and we also talked about Miscellaneous as eBPF. Do you see a difference?
I will be evil for a second. Istio is all in on ambient mesh after denying the existence of eBPF for a while.
And so it goes. If you can't beat them, join them, Victor.
There we go.
So I guess, like, do you see any difference in the type or quality of data that comes from using eBPF instead of using a sidecar?
Yes, but indirectly, eBPF cannot do everything that you can do with the sidecar, right? And that reflecting data, of course. And that's why if you talk with Istio folks, you will hear very often, hey, use ambient now. Now this is a thing. But if you need this and that, then you might need sidecar container. You most likely don't, because it depends on the networking layer that you want to maintain, right?
Cool. Is there anything else we should say about the service mesh?
Yeah, no. I mean, basically, in this context within observability is not really going through service mesh itself. It's more like, hey, service mesh gives you additional data that you should be collecting and doing something with it. Yes.
Awesome. And the one who got chosen from y'all is Istio. So let's see Istio.
Which is very strange because that previously it was Cilium. So different people are joining the channel, watching the channel. That's cool. So here I have, now if you paid attention, I had two containers in this pod. Now, while I was setting it up, we have 3 containers. A second sidecar was added, and that's a sidecar of Istio. I'm not using ambient today. And I can go to, if I go to Prometheus, which I have here, there we go. And if I start typing Istio something, Istio, you will see that now additional metrics are being collected, right? I'm not interested in, we're gonna get to Prometheus later, as I promised, when we get to, what did I want to get to? When we get to, my brain stopped, progressive delivery. And then we're gonna see really metrics and query them a bit and so on and so forth. Until then, here's a very quick view of Kiali. Basically, as I said before, you can collect, and I am collecting metrics into Prometheus. But if you want a separate dashboard dedicated to Istio itself, you have that as well, and then you do stuff that you normally do. I don't know, like namespace, let's say production, and then here's the there are 2 of them. No inbound traffic. Okay, I'm not generating traffic, so we cannot see the application yet. We will see that later, soon. I will start generating some traffic when we get to progressive delivery. For now, what matters is that, hey, there are, you can see stuff. And not even necessarily stuff related, actually, not even always stuff related to Istio, but you can see things. I have no traffic right now. That will change soon, and then we'll see more data over there. Even though we won't use Kiali, we'll just go directly Prometheus. And that's the quick one. There we go. Back to you, Whitney, for whatever. Now you can talk about. I see that you're already drawing. Now we can talk about progressive delivery.
Yeah,
by the way, for everybody here, Whitney is very negative towards progressive delivery. She doesn't want us to go and talk about it because it's boring.
I didn't say
I'm not
that.
inventing this.
We just gave a conference talk about our observability season of You Choose, and Victor wanted to include progressive delivery. And I was like, is that observability enough? Like, I never really thought of, like, when I think of observability, progressive delivery doesn't immediately come to mind. In fact, that's probably a good way to open this up. What is progressive delivery, Victor, and what does it have to do with observability?
Okay, so progressive delivery is about progressively delivering your application. It's about gradually, and when I say gradually, it can be anything between milliseconds and days, moving the traffic from the old release to the new release. And we want to do that progressively or gradually to gain confidence that what we are releasing is what should be running, right? And then within progressive delivery is a very wide umbrella, right? If you're using Kubernetes deployments, you're using progressive delivery, whether you know it or not.
Yeah.
You're using rolling updates, flavor of progressive delivery. What I suspect that Whitney is drawing right now and will explain is Canary deployments, flavor of progressive delivery.
Let's talk about Kubernetes progressive delivery first. Like, why do we need these other solutions, which we're going to talk about rollouts, Argo rollouts, and Flagger by Flux? Why do we need these if Kubernetes already has it?
So what we were doing in the past, usually over the weekend, and if this does not resonate to those listening, that means that you're not old enough. You're not 50 or above. We would go and shut down the application and put a new release on its place, right? And if you're really good, it could be milliseconds or seconds. More often than not, we were not really good, and it would take hours, right? And between the old and the new release, there is a downtime. Your customers are not being served. Now, what Kubernetes does is progressive delivery. By default, it is doing rolling updates, meaning that, let's say that we have 5 pods, right? That's, first of all, and kill me in the metrics if you disagree, it's physically impossible to have no downtime delivery, no matter which method you use, without having your application scaled to multiple replicas. It's impossible. Cannot be done.
Yeah.
I will die on that hill. So you have multiple replicas of your application. It could be 1, but then when you put a new release in parallel, it will be 2. That's already multiple replicas, right? So let's say you have 5, and you want to spin up a new release. What Kubernetes does is that it will create a second replica set that will spin up a new pod, right? And then your traffic will be shared among those 6 pods. And so 1/6 of the traffic would go to the new release, 5/60 of a traffic will go to the old one. Then it will shut down the pod. Shutdown is a whole process. There is a lot involved, but eventually that pod will be shut down, and then that's what you get. And then the story continues. Second new release, shut down the second pod of the old release, and you do the dance. You continue, right? So it is gradually increasing the number of requests going to the new release, right? And that can take any amount of time, anything between milliseconds and whichever amount of time you want. Depends on quite a few things. Usually not long, right? Usually measured in seconds or minutes. That's probably the second simplest way to do it.
Okay.
The simplest way to do progressive delivery, that would be blue-green deployment. And that's, you can fight me on that one, because everybody thinks that's more complicated. It's not.
We'll talk about blue-green in a minute. So that's how Kubernetes does it. And there are a couple problems. One is, depending on how many pods you have running, it's kind of coarse-grained how to split the traffic. Like when you do more advanced ways, you can have like 1% going to the new one. You can have very small. And here you're limited by the number of pods. The granularity is limited by the number of pods you have running. Another thing is, once you start it, it's going to keep rolling out that new application unless you manually stop it. And if the new application is broken, it doesn't know. It's just going to keep pushing forward and rolling out those new pods. And then similarly, there's not a way to automatically roll back. Yeah.
Correct you.
Please
You're
do.
mostly right.
Okay.
It's not that it will not know. It will know if your application is broken by sending Kubernetes in general, independently whether we're deploying a new release or not, has health checks, right? So you can define a health check and say, hey, if this whatever happens, kind of health check does not pass, and Kubernetes would not continue. It would be stuck in 5 of the old one in the new one forever, right?
Okay.
Sorry,
Yeah.
4 of the old one and 1 of the new one forever.
That's
Not
a
forever,
good point.
but yeah.
Until someone manually intervenes.
Yeah. So from that perspective, it is doing that. It's doing checking. It's just that health checks are most of the time not enough. That's the point. Kind of,
You still
it only tells you
have
there
to,
is something obviously wrong. Kind of, oh, this does not start.
and you still have to go in and manually remediate on the weekend, in the middle of the night, when you're trying to roll
Yes.
out something new. So what progressive
Exactly.
delivery does, and then why it's related to observability, is it can pull in observability telemetry data from other sources and use those as a success criteria to decide whether to keep rolling out the traffic. So you can roll it out in smaller increments of traffic. You can roll it out over a much longer period of time, and then you could automate health checks and more advanced health checks that reach out to other services and to observability sources specifically, but also other things. And so that's progressive delivery. And then what I've kind of started to draw here is the example of a canary deployment. So a canary deployment, the name comes from a canary in the coal mine. Like coal miners used to take a little canary bird into the mines with them, and if that bird died, then that meant the air was poisonous and they all need to leave. So if the canary stops singing, it means get the heck out of here. So anyway, on that uplifting note, that's why it's called a canary deployment. And so you might start by sending, 3% of traffic to the new app, and then you could manually do checks if you wanted, or you could use one of these progressive delivery tools to double check HTTP status codes, or make sure that whatever you want to double check that it's working. And then if it's good, then you could automate rolling out more traffic to this new one. So over time, maybe you would have half and half, and maybe this is all happening over an entire day to make sure. And then if it's good, then you keep rolling out. What's Victor, is there like a normal amount of time that a company might take to roll out an application in an automated way?
With checking whether it's behaving correctly?
Like
mean,
with Argo
depends on-
rollouts or Flagger.
Depends on the checks, right, and the scale. If you say, hey, I'm checking whether it's simply working or no, you can do that relatively fast. Seconds, minutes, right? Now, if you do something more complicated, and I'm still going to use very simple example, hey, is the rate of errors within below the expected threshold? It will take longer, right? Because you want a longer sample to deduce that. If it's to 1 second, no errors, right? That's not good enough.
Yeah.
And then if you do something even more complicated, like for example, if you're watching YouTube, you will not notice that, but there is a strong chance that for months you are seeing something that I'm not seeing in terms of how it looks like and how it behaves, because Google would be rolling out their new release over days, weeks, months, seeing how people behave. It's not only about errors, just to be clear. It's kind of, hey, do people like this new feature, right? That could be a criteria. And now that would involve slightly more than only progressive delivery, but still the principle is the same.
So the point with the canary is that it's moving over at a very slow pace with lots of checks. If with these automated checks, there are failure conditions too. If something goes wrong, it can automatically roll back to the first version, so that and you can sleep through the night without getting paged.
Unless you have a database, and then you're in deep trouble. And everybody has a database somewhere.
Which brings us to blue-green deployment, yeah.
Yeah, database is even worse in blue-green, but yes.
So blue-green deployment is where blue refers to the first version of the app and green refers to the second version of the app. And at first you have all of the traffic going to the first version, of course, and then but you run the green version, the new version, and while it's running without any traffic going to it, you do lots of checks in that case. So at first we have all the traffic going here. We have the second one running. We're doing lots of checks. We're using our observability data. We're maybe doing advanced networking things like mirroring traffic to this other one. And then once we're ready, bam, we switch it all over at once.
Just to be clear,
Yeah.
technically it's BAM, we switch all the new ones.
Yes, that's a good point. So two things are happening. There's two reasons to keep V1 going. One is to finish serving all the users that are already in there at the BAM moment. And then two is once we have all the traffic going to app 2, if it's if something's wrong, we can BAM it back over to the first one.
Yep.
Yeah. But blue-green is inferior, seems to canary. Like you'd only use blue-green in a case where you can't use canary for whatever reason.
And this is probably where people will disagree with me. I think that the major reason for using blue-green is really to be able to switch back. And I feel that it's so easy to switch back in Kubernetes that I don't need to run whatever I want to switch back to, right? I can just deploy it.
Have
It
that
could
image.
be AppV3, which happens to have the same tag as V1, right? So it's and I know that many people don't like hearing that and disagree with me, but I think that in Kubernetes at least, or cloud native something blue-green, I'm not sure it makes much sense. But anyways, it's there. You can use it and do with it whatever you were doing before. Now, there are one question, 2 messages from Easy Peasy. I think that's how it's pronounced. So if you have multiple tenants using a service and they have different windows or cutover, at this point, canary deployments do not provide the fine-grained granularity to target a specific subset of tenants over a period of time. Wrong. You can, so let's say that you're using service mesh, right? Let's say that you're using Istio because we are using that today. You can actually, so with Istio, you would have 2 virtual services. One pointing to one application, another one pointing to the other application. Now, what I'm going to do today is change the weight of those services and say 10% here, 90% there, right? But you can configure those virtual services in any other way. You can say people from Europe go to the new release and people from everywhere else in the world go there. Or people who are signed up or logged in go here, people who are not logged in there, and so on and so forth. As long as you can, and that's more or less detached from the tools, right? As long as you can, on a networking layer, and that's why service meshes are, for example, important. As long as you can define the paths, you're fine, right? And after defining the paths, you can say everybody goes here, everybody goes there, right? Everybody who matches this criteria goes here, and everybody who matches that criteria goes somewhere else. And there is another question. I didn't read it myself yet, so I'm seeing it live. How do I convince my SRE to give my team Kubernetes? He wants me to justify why we need it. BTV, we don't have it in prod either. So first of all, if you're a small shop, I'm not sure that you should be using Kubernetes. I don't know, 10 people, 20 people. So put in the comments how big you are, right? But if you're relatively small, and if you're running, let's say in cloud, use Google Cloud Run, use Azure Container Apps, use whatever AWS offers, kind of like don't bother with it, right? Now, if you're slightly bigger, I'm going to give you the answer why your team should use Kubernetes, and that answer will get you fired. And that's, or actually the approach will get you fired. Just go to your boss and bring a physical calendar. Don't do the app, because physical calendar makes bigger impact. Bring the calendar and say, do you agree that we are in this year? Right? Is this 2024? And if that person can say many things, maybe he's traveling through time. I don't know. Right? But the answer is 2024 and say that's why. Not 1999 anymore. All kidding aside, I'm having Ask Me Anything question session next week, Thursday. And we can spend more time on that and give you the real answer if you want.
Awesome. Thanks for the questions. So we've talked about progressive delivery and what it is, and also it's pretty advanced. Like if you're using progressive delivery, that means you've figured out. You probably have a service mesh going because that's going to help you do the fine-grained traffic splitting. You probably also have some sort of observability data being captured and being able to be queried. So this is something that happens further along as your system matures.
Let me put it this way. Don't think about progressive delivery. At least, no, okay. So there are actually two ways you can do that. One is manual. And stop me, Whitney, that's what you plan to talk later, right? Manual and say 80% here, 20% there. I'm going to watch what my some dashboard something as if it's replacement for Netflix and make a decision to say continue, right?
Yeah.
You can do that. That's relatively easy. Now, what you really want to do is to automate it. And it would be foolish to start even thinking about progressive delivery until you have observability well handled, right? Kind of like you know what good means and what bad means.
Progressive delivery is your reward for being good at observability.
Exactly.
Yeah.
Kind of if you can, let's say as an exercise, right? Kind of if you can define a list of queries. You need queries to create dashboards yourself, right? Kind of, if you're capable of creating dashboards and those dashboards are reliable, and you can deduce whether something is working as expected or not through those dashboards, that means that you know how to write queries, and that means, writing queries is that you know what to observe, and your applications are providing information you need. Then you can move to progressive delivery, and that's when all our audience dropped.
Let's talk about Argo rollouts versus Flagger. They work very differently under the hood, but they have the same outcome.
Okay.
Did you hear what I just said?
They work differently, but they have the same outcome. They're different, but the same.
They're different, but the same. The exact same outcome. Flagger is by the Flux project. Argo rollouts obviously is by the Argo folks. Does this have to do with GitOps?
Nothing to do with GitOps.
Nothing to do with GitOps, except for the same tools that make our GitOps tools also make progressive delivery tools.
Yes, at least in case of Flux. Or at least Flux v2, because v1 is a nightmare that nobody understood how it was created and why. Flagger came first.
Flagger came first.
Yeah, I'm not sure in case of Argo which project was first. I would only guess that Argo rollouts came into existence before CD. But that does not mean that one depends on the other, just to be 100% clear.
And they both work with Kubernetes deployment objects, but Argo rollouts additionally works with its own rollout resource that you can use to define your conditions for progressive delivery for how much traffic you want to send to the new service and how quickly and success conditions and such. Also, Argo rollouts can roll out from many resources to many other resources, right?
That's what I thought, and I was wrong, and I was corrected, and I admit my mistake. No, that was the idea that was never implemented. And I went through PRs. Yep, I thought that was closed long time ago. It's not so. It works only with deployment, except the major difference is that Argo rollouts can create a deployment for you. You can reference existing code deployment. If it's not deployment, tough luck. Try again maybe next year.
It can be a rollout. also a rollout custom
Yeah, but the
resource.
rollout creates then, so either rollout creates a deployment or you instruct rollout to reference a deployment.
Okay. Okay. Cool. So they're about the same. And the one that got chosen was Argo rollouts. So it's time for a
I
demo.
expected that's a cue for me. Yes,
That's a
it
cue
was
for you.
Argo rollouts. I'm trying to set it up. I will eventually do it. The fact that I'm not looking at any of you, that's because I'm looking at my second monitor, and Argo rollouts should start appearing on my screen soon.
Make sure you
let's
share your
put on
screen.
my screen.
Yeah.
There we go. There we go. It will appear here. I'm just waiting for it right now. I don't know why it's not there. It will eventually appear, hopefully. I'm actually proud of myself. Oh, okay, there we go. It's there. It stopped, and we can. I'm going to load the environment variables created from my script. Cool. Okay, rollouts is installed, right? And what I'm going to do is two things. First, there you can define your queries inside rollouts, or you can define them outside. I like outside because it's reusable, right? And then we can define something called analysis template. It could be cluster level or namespace level. And here I'm saying, you know what? This is a template, and there are some arguments. I will fill in the value of the service name when I start using this. This is the address of Prometheus that will be used, and this is the address of port. Sorry, no address of port. Port of the application, right? What really matters here are two things. Three. First, this analysis is called success rate. You will see it in action soon. Second, success condition is that if the result of some query somewhere is more than 95% or 0.95, then it's okay. You're successful. Any number lower than 95%, it's trouble, right? And query here essentially says, you know what? Take the rate, the sum and the rate of all the requests from Istio, filter those requests so that they come only from the service, whichever name of the service we specify. And the request must be different than 500 or 400 codes. So basically, give me all the OK requests. Exclude all the errors, right? And then divide that with all requests. So basically, all without errors divided with all requests, that should give you the success rate. So that's the that is the what they want to say. That's the analysis, the query we will use, and I'm going to now commit and push to Git, and at one moment the analysis template will appear in my cluster. You don't see it on this screen, but I'm looking now on my second screen for the Argo CD UI, just not to wait until it gets to synchronize it again. I'm refreshing it, and now it should appear. There we go, right? So the template, the query is in a cluster. And then we can move to the application. Now, application, I will first execute, I will make a few changes to the application. They're not important. Just I have a flag in my application to enable progressive delivery. Now, what does matter is first, I will change the number of replicas of my application to 0, right? Because Argo rollouts will be changing the number of replicas for me. And I will generate new YAML. Here we go. Now, there are a couple of things important here. First, since I'm using Istio, there is virtual service. Basically, I'm saying, you know what? There is a virtual service called CNCF Demo 2, and that one should send 100% of the requests to the primary service and 0% to the canary, right? So basically, if I just apply this, all traffic goes to the primary replica of the application. and there is a second virtual service, same logic, all goes to the primary, meaning the main release. And then what else? I have two services. That's easy. Table for the database. That's also cool. Nothing really special. I will eventually get... Okay, gateway, because we're using Istio, that's going to replace Ingress. And my application itself, right? I'm not changing my application. The only change to my application is that I removed, put number of replicas to 0, right? And the last and the most important thing here is this one. This is what really matters. That's the rollout. And basically, I'm saying, hey, if it's a canary, meaning a new release, this is the service that you should talk to. And if it's a stable release, the current release, this is the service. Do routing through Istio, right? It could be some other service mesh, or without service, it could be Ingress and so on and so forth, right? And those are the services you should use. This is the analysis, success rate. And this is actually where the real thing starts, right? Use success rate analysis, what we saw before. And start analyzing after step 2, right? And everything else is steps. And that means increase the weight to 20, meaning that when you start sending requests to the new canary, 20% of the requests, everything else goes to the older canary. Wait for 60 seconds, then increase the number of requests to the new release to 40, wait, 60, wait, 80, wait, right? So it will be progressively increasing the number of requests going to the new release 20% at a time. But since we said start analyzing it from the step 2, it will start analyzing here, right? So basically, after 20% of the new release is operational, then it will start analyzing, just not to get wrong results or results based on nothing. So it's that's it, right? Just specify how to progress. What are all the steps in the delivery, and how to query to deduce whether something is okay or not. And then I'm going to push this change to the to Git, and I'm going to watch Argo rollouts. And it's not found because Argo CD did not synchronize it yet. I will go there and speed it up. Now, if I start watching, you might see, well, there we go, right? You can see here, I'm sorry, but Zelige is blinking like crazy. I probably need to make it smaller to stop blinking. Okay, this is less blinking. Okay, can we do, okay, more or less. And you can see that it rolled out immediately, right? It did not do any analysis. It did not wait for anything simply because it makes no sense to do analysis for the first release, right? There is no second, there is no previous, it's nothing. So what I'm going to do is stop this. I'm going to go to a second terminal session. I have multiple windows here. Here, and I'm going to start sending requests to the application. Let's see whether this is working. So I'm just bombing my application to simulate as if this is real production, right? For half an hour, or for an hour. Okay, cool. Now, if I go to Prometheus, here is Prometheus. No, sorry, that's not Prometheus. This is Prometheus. Let me show you the queries first for you to understand, right? This is the total number of requests, basically, is your request total. This is the metric sum. This is how many requests I got in last forever, probably. And this is the query that that's the same one from analysis that I will execute in Prometheus, and you can see that the output is 1, right? Meaning 100% of the requests are okay. I have no failures. And that's the same query that Argo rollouts will be executing. So let me move this out. Let me move this out as well. This is my terminal. I'm going to update my application to release 002. Right? Push it to Git. Let Argo CD do the job. And then over here in a smaller terminal, let's do this. Over here, I will be sending requests to my application. You can see, no, sorry for that. Okay, let's see whether it works now. There we go. So you can see that now all requests are coming from release 001, right? 100% of them. Now let's see when Argo CD detects the change. It will eventually synchronize it into the cluster, that change of the tag. And slowly here you will see that 002 will start appearing. And it will be approximately 20%, 1 out of 5 requests, if this works. In the meantime, let's watch in the top one what is Argo rollouts doing. So it did not start yet. It will eventually start. Maybe. Or maybe it won't. Come on. Okay, let's see what's going on. Namespace, Argo CD, port forward. Something wrong. I'm disappointed in myself. Argo CD server 8080. Let me see what's wrong. No, nothing is wrong. What am I talking about? Look at me. I'm silly. Did I see number 2? Yeah. You see that some requests here in the bottom left are saying release 002. Some are 001. I was just impatient. I'm never patient enough. And you can see that now it is paused, right? It is waiting for those 60 seconds, if I'm not wrong. And when you see the 60 seconds here, it will start increasing the reach to 40% soon. And while it's doing that, I mean, eventually, maybe, there we go. Now it started analysis, right? You see here, this one here, small, that says ticked 1. That means that all my queries are passing. It's successful. I have only one query, right? So as long as it will continue querying, and it will continue waiting while querying and analyzing, it will continue doing that until the very end. And it will continue, in parallel, it will continue waiting for 60 seconds. And then 60-something seconds later, you will see that there will be a new pod over there. And it will be increasing to 60%. Now, pods are not important here. It's just I put them because it's easier to visualize. It's not really balancing requests based on pod, but based on virtual service weight, right? So it is updating virtual service to redirect traffic to pods of the old release or pods of the new release. And before we continue, trust me, this will eventually finish. It will take too much time. I'm going to create a third release. I'm going to do this very fast, try to do this very fast. Okay, third release is about to be pushed to Git. And I'm going to bomb my application, simulate traffic. But I'm going to simulate. You see this failed through? I have a flag in my application. It will be intentionally failing. It will simulate failures. You see that all the responses are 500. So I'm simulating failure of my application. And then eventually this, no, not that. What am I doing here? This screen will eventually, what's wrong? I know this is, well, of course it's wrong. I'm using Flugger here. No, it's Argo rollouts. Here we go. Eventually, okay, I might show you a screen later. Eventually, it will start deploying the new release, the third one, and it will find out that it's not working and that it is not passing the tests, and it will roll back. That's what will happen. Eventually, few minutes, probably 5-6 minutes from now. I don't want you to be glued to the screen waiting for me waiting. That will happen eventually. I'm going to come back to show you that. For now, we can move to the next, I think, last section, right? Whitney?
There's two more.
Two
The next
more.
one,
Oh,
two more. The next one is cost.
cost. Cool. I did not prepare. That's the second I didn't prepare. So
No demo for this one.
no demo for the cost. Your cost is high. You don't need. Oh, wait. Let me show the screen. Just since it's there. You see there the red one saying, Victor,
Fail.
you're an idiot? That's what's happening. And eventually it will roll back. Actually, you see here 001. It rolled back to 001. Now you might be asking why it's not rolling back to 002, because 002 did not finish rolling forward. So that one I interrupted it just to be fast, and it rolled back to 001. Mission accomplished, I failed. I mean, the demo worked, but the release, not a good one.
Awesome. That's super cool. So for cost, we have 3 projects. I mean, cost is pretty self-explanatory. We want to spend less money, not more money, for those of you who didn't know. We talked about OpenCost and StormForge and Cast AI as our 3 tools. I have a question. Is it true that cost is more about right sizing than like using the cheapest available resources?
Yeah, I mean, there is a bit of cost there, but I feel that cost is a side effect of you right sizing things automatically, right? So you need to figure out how much memory and CPU and these days GPU your applications need, and define them as such, and let Kubernetes figure out the rest, right? When applications are concerned. So it's about finding out how much resources your applications need, and it's about being able to scale your applications and your clusters up and down, right? Kind of like, hey, I need more nodes. Let there be no more nodes. I need less nodes. Let me remove. We can debate for a long time what is the target metric, but let's say depends on the size. Anything between 70 and 90% of utilization is good, right? Depends on the size. More than 90 utilization is dangerous, because then you don't have maybe room to maneuver.
For spikes, yeah.
But something like that. Now, let's say 80, 90. Most companies, there are some studies there, most companies have around below 50% utilization.
Oh,
right?
I didn't know that.
Less than 50% of their memory and CPU that they're paying for is used. And then you say, are we idiots, or what's going on here? And I've been in companies, that's data that I've seen. I've been in companies that's around 10 to 15%. It sounds unbelievable, but it's only unbelievable because nobody checked it before.
I feel like a salesperson at a cost-saving software company has to be like the easiest job.
Basically, those solutions, basically, they need to do 2 things. First, to convince you that they work. They might or might not. And second, to tell you, you know what, if you give me money, I give you more money back. Kind of basically, you pay me 100K, and you will save 200K. Kind of, it's a no-brainer. Kind of, yeah, of course.
Yeah, unless I can figure out how to do it myself, which probably I can't. So the 3 tools are OpenCost is the first one. OpenCost it's a reporting platform. So it's going to tell you about what you're doing, but it's not going to actually do anything to optimize for you. It's giving you information, but not changing anything. Is there anything you want to add to that?
Yeah. I mean, it's slightly more complicated than what I mentioned before. One thing I forgot is that the fact that your utilization is correct does not mean that you are that you're paying the right price, because hey, it might be 90% utilization, but you know what? You're using expensive nodes, and the cheaper ones could do, kind of spot instances could do the trick, right? Or maybe 20% of it. So there's a bit more, and that's where those reports are very, very handy, right? It will give you the utilization. It will give you also, hey, are you not only underutilizing resources, but also using the wrong ones?
Yeah. So the reports for OpenCost at least will give you recommendations for remediations on places you're overspending, in its opinion, but it doesn't do anything. And then StormForge is a tool that right sizes Kubernetes workloads. So it's focused on right sizing. And it uses machine learning to identify trends and what you need. And so it's able to predict your utilization, and maybe you have smaller margins that way if it can help predict where your spikes are. But it works with, under the hood, it uses OpenCost, and Carpenter came up as part of this episode too. What's Carpenter?
Scaler. Basically, it scales stuff.
Nodes.
Huh?
Nodes specifically?
Yeah. Yeah, I'm always mixing Carpenter with Keda.
Keda.
Nodes born in AWS, for AWS, but it's open source. And I think that, if I'm not mistaken, Azure is now adopting Keda as well, I think. And I've heard, actually, this morning, I got, people send me information and stuff like that. Hey, now Keda is available for Alibaba. So it's free.
Keda's an event-driven autoscaler, but it doesn't just scale nodes. Carpenter's for nodes, I think. Anyway.
Yeah, Carpenter is for nodes. Was it saying Keda all the time?
You said a little bit of Keda, but I think you meant
whenever I said Keda, I meant Carpenter.
Carpenter, yeah.
Yes. All day, again. It's killing me.
Literally. We have a comment, but expect Kubernetes is important to have data about all services of a cloud provider as part of cost.
No, not necessarily. Without entering whether it's better to have or no, those tools can connect to your cloud provider. So, in general speaking, without entering into specific tools, you give them basically access to your AWS account or something like that, or create a new AWS user or whatever you're using, and they go there and they can figure it out. So think of it more like a combination of information from both what's happening in your cluster and what's happening in AWS or Google Cloud or Azure. So that access has two actually primary reasons. First, to find out what's happening there. But just as importantly, at least within a context of cost, to find out how much you're paying. Right? Because if you want to get close to accurate information, you cannot just say, the cost of this size of nodes in AWS is this much, because a bunch of people tend to have different prices. Right? I have the same prices as other people because I don't have a special deal with AWS. But companies bigger size at least almost always do.
So the third tool is Cast AI. I have a question, but first I'm going to say that Cast AI, it does the reporting that OpenCost does, and it does right sizing too. I don't know if it does the machine learning part, but what it also does is optimizes the node selection and automates using the spot instances that you mentioned earlier. So that's what Cast AI, and it makes those cost-cutting changes to the cluster automatically, which leaves me to my question, which is, aren't you supposed to define everything declaratively? If you're hopping around spot instances and cloud providers and stuff, you're no longer managing your resources declaratively.
No comment. You should, of course, kind of like I'm a Kubernetes freak. I see my no comment doesn't last more than 2 seconds. I think that you should be. No, it's not about declaratively. It's about being able to control and define things through Kubernetes API. And I would be a happier person if all those tools would use UIs to observe the state of something, including cost. I think that's great. I like UIs for observing stuff. I don't like UIs for controlling things. But yeah. We would need to have a longer conversation about that.
I am interested because if you really are saving a ton of money, I would want to understand why I'm choosing declarative over saving $100,000 in cloud costs. What benefit am I getting? if I'm choosing, I'm like, okay, I don't want cloud cost software to be able to mess with my declarative architecture. What is my benefit that I'm getting
it's
for
not
the
messing
100?
with your declarative architecture. Just to be clear,
Mm-hmm.
all those tools. So think of it as three different levels of what those tools do. There are probably more, right? One is to, and all of them do that, to give you the information. Hey, kind of like utilization of this cluster is on average this much instead of that much, right? Things like that. Then the second layer would be, here is the recommendation of what you should do. Kind of change the size of the nodes to this, or change the number of the nodes to that, or the amount of memory CPU in your application to that. And in that layer, they will almost always give you that information, but always sometimes, depending on the tool, give you the snippet. Kind of, hey, if you put this into your Kubernetes manifest or whatever it is, you will be good, right?
Okay.
Gives you snippets that you can put into your applications or your cluster tools or what's not, right? And then the third level would be, and this is the part that it's a bit more fuzzy for me, we can automate things, and we can automatically scale your cluster up and down, for example, right? And that's great. I like automation. But in quite a few of those tools, you cannot define and say, hey, that automatic scaling, just as CAD is automatically scaling, this is something Kubernetes resource that I put to my Git and let Argo CD synchronize it, and my cluster knows how to scale itself, right? Very often, that operation of scaling itself is only available by clicking buttons. Kind of enable. It can be a single button, kind of enable scaling, right? And that's where it becomes a bit fuzzy. But other than that, so think of it three layers, right? Kind of information, suggestion,
automation.
action.
Yeah.
Automation, yeah.
So the one that won the vote was Cast AI, but that's not a CNCF project. Neither is Stormforge. We just added them to have a conversation. And so the only CNCF project in the bunch
to
is
give them
OpenCast.
false hope as if they could win.
Exactly. So OpenCast was the one, but Victor's not going to demo it because it's not ready, and that's okay. We
Sorry
have
for
that. One more system design choice that doesn't in a demo, and this is what we covered just right before KubeCon, which is our miscellaneous episode, which is always a lot of fun to see what the weirdos are up to. I like the weirdos.
By the way, Whitney, just in case
yes.
you're not aware, you probably are aware, but just in case you're not, we can hear you, we cannot see you. Now you started moving. Okay, you're back. I just need to remind you to move. Okay, cool.
Oh, I was just holding very still. Oh, okay. In my world, I wasn't. But anyway, thanks for telling me. So we already talked about Pixie, which was one of our miscellaneous ones. So the ones we're going to cover are Kepler, which is an exporter, a Prometheus exporter that uses eBPF to probe CPU performance counters and Linux kernel trace points. I'm obviously reading that. I don't know what I just said, but I do know that it's a Prometheus exporter that helps you understand how much energy your workloads in your system, each component of your system is using. So it's helpful.
One interesting thing about it, not specifically Kepler, but if you remember earlier, I said kind of you're going to have Prometheus even if you chose something else.
Yeah.
Right? That's an example of a project that, hey, we need to export data somewhere. Where is the first place we're going to export? What is the golden standard? Prometheus, right?
Prometheus.
And then eventually they might start exporting elsewhere.
If you go to the Prometheus documentation and look up exporters, there are like hundreds and hundreds and hundreds of exporters. OpenCost actually is a Prometheus exporter that we just talked about, I'm pretty sure.
As well, yeah.
And then the next, so that's Kepler. Then there's Kate's GPT, which is a tool for scanning Kubernetes clusters, diagnosing and triaging issues in simple English. So it says it could give Kubernetes SRE superpowers to anybody. We had a philosophical debate if about whether if someone hands you, like, how much you need to earn that knowledge so that you can build on that knowledge as opposed to just having it handed to you, which is a more general problem with AI, maybe, depending on what you think. So that's Kate, or the whole internet. Good point. The next one is Inspector Gadget. So it's a set of tools for data collection and system inspection that works on eBPF with eBPF. So it works with Kubernetes and Linux hosts. But when you use it with Kubernetes, it's almost like an orchestrator. So you can install that eBPF program across all your nodes, which is pretty cool. And besides being a collection of tools, it's also a framework. So if you want to be able to write your own eBPF tool that runs on Kubernetes, Inspector Gadget gives you the framework to be able to do that. And the last weirdo is Perses, which we talked about at the very beginning. It's a dashboard, but it's not a Kubernetes dashboard. It's an observability dashboard. And more than that, it's a specification, a dashboard specification. So right now it focuses on metrics, but it wants to handle all the signals eventually. Give Grafana a run for its money, open source.
Yeah, it's kind of attempt. To me, that sounds like similar attempt like hotel, right? Kind of, oh, can you kind of create a specification or standard how dashboards are created, no matter whether you will be creating them in that tool in Perses or somewhere else.
Yeah. Is there anything you want to add to that, or shall we talk about the chosen technology?
Yes, the chosen technology is Inspector
Who won the vote?
Gadget.
Inspector Gadgets.
Yes. And Gadget, so I already installed it in a cluster. It's running its eBPF, what's not. That's
nice.
Helm install. What matters, let me make it bigger again. If you look at the help, you can see that there are commands split into categories like advise. Oh, you're putting the screen. There we go. Advise, audit, completion. Completion is not really, but deploy doesn't matter. Run, snapshot, sync, top, and so on and so forth, right? So the way I see it, and authors don't explain it like that. I see it in a very similar way, like Linux, right? It's all small commands that are very specific and do specific type of things. You might want to pipe one into the another and so on and so forth, but basically very specialized set of tools and kind of grouped. It's more like a group of tools and highly extensible. Anybody can write tools. And I haven't written one yet for Inspector Gadget, but I understood it's actually relatively easy and straightforward. It's interesting, even kind of, you might want to write Inspector Gadget add-ons or whatever it's called, plugins, if you want
Gadgets.
to have eBPF doing something without really diving deep into eBPF yourself, right?
Yeah.
So let's say that I want to do something about tracing, right? Because we did that before. And again, help, and then you can see that within each category there are additional, like, hey, bind and capabilities and DNS and exit and so on and so forth. So let's say advise, mostly because you were mentioning Whitney kind of AI, what's not, because AI is all about that advising stuff, right? So that would be advice. And then I want to get a recommendation what to do with network policies, right? Within network policies, I would like first to monitor the traffic in my cluster, right? So I would like it to observe what's happening in my cluster to give me a recommendation what to do with network policies. And I want to specifically in the namespace production, and I want it to output it to network.json, right? And run that in background. So right now, did I misspell advice? How do you, Whitney, English is your native. You should have corrected me.
Even with your voice, you said advise. I'm like, that's a weird command, but okay.
Okay. There we go. So now the next thing I'm going to do is send a request to my application just so that there is some traffic. There we go. You see that it continues recording, and I'm going to kill it. It's enough, right? You would run this for a longer period of time. But so it was looking what's happening in my network, and it was dumping it into a file. And if you look at that file, you can see that here it found out what's happening in my network, right? Those are the requests that were floating in my network. Too much for me to show you each one of them. Just it collected information of what's happening related to the application, that namespace, what's or not. And now I can do the same command but report. Okay, now create a report based on that network traffic, and that report is this YAML, right? Those are, in this case, network policies. So you've created network policies that will allow the traffic that is currently happening and disallow traffic that will not be happening. And now I would be just kind of apply this to my cluster, and I have network policies created and save myself from misery, because creating network policies, writing them is just miserable thing to do in Kubernetes. What else? Let's say I have another command like I want to see the snapshot of the processes currently running in the production. So this is processes, not containers, what's running in those containers, right? And actually beyond. And you can see this is what's happening. I can see now what's happening in my cluster, what specific processes are running, and do whatever I need to do, right? Okay, one more. Let's do one more. Let's do gadget. Let's say top eBPF processes. Now I want to see which eBPF, I'm going to use eBPF to find out which eBPF processes are running in my cluster. And there we go. There's a bunch of things. Auto, something. I mean, it's moving too far for me, too fast for me to see what's going on. I would need lower resolution, more screen. Anyways, those are the top processes. Just a top command in Linux, except that it now knows what's happening in your cluster, which is awful. Did I say awful? Awesome.
We're like over 2 hours into the stream, so we're doing great.
Yeah. Okay, that's
amazing.
That's Inspector Gadget,
and that's a wrap. That's a whole season of observability in 2 hours and 15 minutes.
There we go.
Everything I hoped and dreamed it would be, Victor.
Your dreams came true.
They really did.
Okay, I can tell you, Whitney, here's my advice for you: get better dreams, please. Aim for something better than this.
Okay, so we're going to see you again in maybe January or February for season 5 of You Choose, where we're deciding between covering internal developer platforms and covering automation. Those are our choices.
Yeah.
But you don't get to choose. Victor and I are choosing this one.
Yeah. You have no say in this.
No, you
I don't know. Witten does not even know why we are informing you about the fact that there are multiple choices when you have no say in it.
Yeah. Just
She's an evil person.
Every once in a while, Victor and I choose something. So we'll see you next season in 2025, and have wonderful holidays. And that's awesome. Thank you for hanging out with us. Bye.